Good afternoon, everyone. Welcome to FPSA's Fall Operations Series, Data-Driven Maintenance as a Margin Enhancer. This is the fourth in a series of 5 webinars. The next one is on October 23, called Disaster Prevention and Contingency Planning for Operations. And you can register there at fpsa.org/fall. As we're proceeding through the webinar, if you have any questions at any point during the webinar, please use the Q&A feature on Zoom at the bottom, the left-hand corner of your screen. That feature allows you to ask questions in writing, which we can answer verbally during the webinar or in text back to you, or follow up with you after the webinar. So let's get started. My name is Tom Wiersma. I handle all of the marketing and business development planning at Integrated Packaging Machinery, IPM, and I am the chair of FPSA's Technology Network. Now I'll ask the expert panel to introduce themselves. And remember, these guys want your questions. They're smart guys, and they're hoping for some tough questions. Tony.
Yeah, thank you, Tom. Tony Simpkins, good morning, everyone. Senior Manager of Pervasive Sensing Business Development in North America at Emerson. As you can see, I reside in Myrtle Beach, South Carolina, and come to this presentation with a little over 12 years experience in instrumentation and automation.
Thanks, Tony. John?
Thanks, Tom. My name is John Tertine. I'm the Director or Vice President of Digital Transformation at Cybertrol Engineering. Cybertrol's a process controls and manufacturing software integration company, been around since 1996. I have a strong background in computer science, and specifically have spent the last 10 or 15 years deploying software into the manufacturing space.
Good deal. Thanks, John. Ed.
Hey, thanks, Tom. My name is Ed Ladd. I'm the Director of North American Solutions Architecture for the Emerson's Measurement Solution business. I've spent over 35 years in automation, control, many different industries, food and beverage, CPG, focusing on automation, measurement, and then in the past 15 years, focusing on field communications and industrial networking specifically. So I'm your IT OT guy that can speak both languages. Thanks for being here.
Thank you, Ed. So today we'll be covering, as you can see, in summary, sources of data, how to integrate that data successfully, and then how to manage the data. And there's a lot of content here and a lot of depth and a lot of issues that you, our audience, may want to dig deeper into, and that's the purpose of this. So feel free to ask those questions. This is also a kind of brainstorming session, so as much time as we have, we will spend time digging into some of those issues. So bear that in mind, and please do ask questions. So let's get started. Tony.
Absolutely. Yeah, absolutely. Thanks, Tom. So I'll be covering today data sources. So where we get the data, where it all begins, where we pull that data out of our processes, out of our plants or facilities, to get the process started toward good data management. Next slide. Okay, so food and beverage landscape has specific challenges. You know, as we look over here on the right-hand side, you're going to see there's always a demand for increased efficiency. That changing environment, you know, it's a very fluid industry where things are changing very readily. Too much downtime is costly and impedes productivity. Those are things that affect your reliability. So now we've dealt with production and reliability. And then there's the quality, out of spec products, improper storage conditions that drives up cost. And then, as if that isn't all enough, then on top of that, we're now working toward high sustainability efforts, excess water use, trying to limit excess water use or greenhouse gas emissions and waste that ultimately hurt sustainability efforts. So let's take one example. We could obviously go through a plethora of different examples, but we picked one today in the interest of time that would affect most of you, and that is pump monitoring. Continuous monitoring is possible on pumps through a variety of different measures or measurements and data sources. As you can see here, we can look at things with gauge pressure, such as pre-cavitation, cavitation, low discharge pressure. We can check the DP across the strainer to indicate clogging. We also can use vibration measurement to give vibration and temperature indication on a bearing shaft, as well as level indication on seal pot level to make sure that lubrication is still present in the pump. And also we can check for leaks with um, discrete instruments that check for change of state and leak detection. So all these things come together to give us a whole picture of what's going on in one of our most critical assets, which are pumps. And what you'll notice about this screen is that all of these can be done wirelessly through a wireless HART infrastructure. So let's go to an example. In this example, this kind of gives you the idea of not only what you can monitor, as we saw on the previous slide, but also what kind of real world dollars and benefits this can bring. Obviously, you see the challenges here for pump shutdowns, causing reduced production, maintenance expenditures over budget, insufficient data. And that online pump monitoring solution gives you that early warning system that doesn't necessarily need a machinery expert to interpret. You're going to be able to get such indications as pump vibration, cavitation, bearing temperature, strainer plugging, seal leaks, and eliminates those nuisance alarms that many times come with not knowing exactly what's going on in the asset. As you look over here to the right hand side, you'll also see that this produces a pretty good qualified business result. These are industry averages on a customer investment of 10 to 40 pumps, which could be anywhere between $120,000 to $460,000. You're looking at a customer savings of somewhere between 76K and 303K on a 17-month payback average. So it's a pretty good ROI on your investment. So how do we accomplish all this? What's possible? Well, wireless devices, because of the lack of cable tray, conduit, engineering that is required to put in a wired counterpart, they eliminate cost, reduce complexity, accommodate change very quickly and easily, allow you to ensure safety by adding missing measurements points very quickly and easily, and can improve your overall reliability. And many times we divide these two things, or these types of devices, into two different categories. That would be process monitoring, which you see in the middle of the screen with pressure, your standard pressure devices, DP, that sort of thing, as well as temperature, both intrusive and non-intrusive temperature, as well as level and flow devices. On the side of reliability monitoring, which is the other major category that we divide these devices into, you're going to be able to do such unique applications as vibration, acoustics for leak detection and alarming on PRVs, discrete signals that literally indicate a change of state that can be used on a variety of things from switches to lights to alarms, all different sorts of things, gas monitoring, corrosion erosion monitoring that measures wall thickness, corrosion, where corrosion erosion might affect that wall thickness, um, and just a whole plethora of different solutions that can be utilized in the wireless space.
Thanks, Tony. As long as we're on this slide, is it possible to identify where most customers are seeing most of the problems most of the time? Is it process or is it reliability monitoring?
Here's the thing, where we get the biggest bang for our buck in wireless is in the reliability monitoring. Things like the acoustic that can be used on steam traps to indicate when a steam trap has failed or is either you've got condensate backup in the system causing the trap to go cold, or you've got the trap is blowing steam on the ground. Steam is very expensive to make, and you definitely don't want to be using that used energy to be blowing that steam on the ground and wasting it. That device also can be used for pressure relief. So any releases to atmosphere, that acoustic can detect it. Vibration is another one, like we mentioned before. Some of our most maintenance sensitive assets are our pumps, our mixers, our motors, our rotating equipment, and the vibration does a really nice job there. So I think that probably those are the biggest places we see it. We always see process monitoring devices, but a lot of times where wireless is the most helpful is in that reliability monitoring because it gives you vision
Okay.
into things that you normally wouldn't see.
And how how quickly would you say that customers are ready to engage with wireless devices?
It's funny when I started this like 7 years ago. It was very cautiously. It was we don't a lot of times people were very cautious about we don't trust things without wires. And now my schedule books out several months at a time with people saying, "When can you get in here and talk to me about this?" And the reality of it is there's a significant savings. All that wiring, conduit, engineering. You can save between 40 to 60% of the comparable wired solution by utilizing wireless. So the acceptance, and I think probably the cell phone has increased
Yeah.
people's comfortability with wireless technology, and so now it's just a matter of when can I get to them? I'm not begging for appointments. Several years into this.
Okay. Thank you.
Yeah. And so finally, so you've got all this data coming from these different data sources, and you're pulling this rich data out. What do you do with it? So you've got data from pumps, rotating equipment, conveyors, motors, fans, mixers, pneumatics, your compressed air, another expensive thing to produce and to maintain, vacuum systems, your utilities, steam traps, boilers. The list kind of goes on and on. Bottling, palletizing, blending, pasteurization. You've got all of these different individual measurement points. All that is fine and dandy if unless you do something with it. So what are you going to do with this? And this is where we kind of transition. I'm going to kind of hand the ball over to Ed, where he's going to discuss what we're going to do with all these rich data points and how we're going to put them together and bring them to something that is very actionable.
Hey, thank you, Tony. Appreciate you. Let's go ahead and go to the next slide. We'll begin the discussion about data integration. Next slide, Tom. But first, you have to take the information that Tony just discussed, the individual measurement points, the thought processes of the machines, and think about it where reducing maintenance costs can actually affect and improve your bottom line. The fact of the matter is improving reliability adds to your bottom line. There's no doubt. But as operators, we typically are responsible for operations, not innovations. So it's getting that thought process beyond the plant floor, the factory floor, up into the management offices so they can better understand that moving from a run to failure or reactive maintenance program to a system that's more of predictive and based on using analytics and direct sensor inputs is key. But you've got to break it down into the different elements, moving from the business systems, work management, and actually taking it all the way down to the plant floor to the individual devices that provide you the information and then bringing it back up. It's almost a full circle to help you understand how that data flows through the process. But once you've begun that transition, there are many things that you need to think about. But the bottom line is improving reliability can improve and will improve your bottom line experience, keeping that update and getting that overall equipment effectiveness that you're looking for.
So that 10% maintenance reduction number is fairly commonplace.
I would say in many cases it's actually more than that. What I've seen in the past from working with food manufacturers in particular is it not only improves maintenance, automation, and connectivity actually increases your production capacity. It reduces your cost from a labor perspective because now instead of having one person every 3 to 10 feet, now you've got one person overlooking the machine that's operating it, and your staffing moves to a higher technical level than it did previously when you were doing manual operations. So when you're thinking about these applications, I mean, it's one of the crazy things that we have to deal with from a food and beverage machinery manufacturer standpoint. Only a certain percentage of a plant, let's say, is stick built on site. The majority of the machines that come in are built in a faraway place and are delivered complete, put into place into a plant, and do not come with the visibility information that we're talking about. I mean, as I mentioned, operators are there to operate. Well, machines are there to operate as well. They're not designed to self-diagnose typically. And in many cases, the machines that we're using are 10, 15, even 20 years old. I've been in some factories where I've seen some post-World War II equipment still in operation, still working, still using the pneumatic systems and being piecemealed back together and again and again. Well, that's truly looking at it from a run to failure perspective rather than the predictive monitoring perspective that we're talking about. Only replacing those components that are necessary to really keep the machine operational rather than try to improve performance. Without that visibility on those machines, they're really islands of automation, that you can't deliver that diagnostics from. So first, you have to eliminate the islands of automation component. You have to connect all the systems together to be able to get that data out. Well, connecting the systems together is not enough. It's enough. You have to do it or look at it and engineer it from a we call it zones or segmented solutions. So your equipment is zoned in specific areas. So you're not worrying about, is it my network that's causing a problem? Is it my machine causing the problem? So you can get down to brass tacks to really understand where that connectivity is. And that can be done at the machine level, at the edge level, at the on-prem level from a server perspective, or all the way up into a cloud. I mean, improving the performance of your assets seriously increases your bottom line, reducing downtime, lowering maintenance costs, and improving the asset performance overall. Most people look at it as overall equipment effectiveness from a delivery standpoint. Well, understanding how effective your equipment is extremely important to delivering those results.
Thank you. And so that reference on the slide to reduce downtime, is that 22% number that you're familiar with? I mean, across the board, is that food and beverage related, or what would you say?
In this particular case, it's all food and beverage and CPG. It's kind of an industry norm or industry discussion that's had across the board. So that's a great comment, Tom. I mean, these are real numbers and real aspects that you can achieve, but it depends on how much you implement it and how you use the information to correlate that into a bottom line. I mean, the problem that I've seen with most manufacturers, they don't understand what downtime costs them. They haven't boiled that down to a number. And if a manufacturer can boil that down to a number, then they can see, if I make an improvement of get an extra hour out of that machine, how much additional production did I just make by having that reliability built into that hour?
Okay. And then for those of us who may not quite know what that means, what is, in this case, what does the edge mean? Maintenance at the edge. What does edge refer to?
Excellent to discuss. It's always about acronyms and the EIEIO of alphabet soup. I mean, today, edge and cloud are kind of pervasive. If you look at some of the instruments Tony presented previously, we've been doing processing of information at the edge, converting a differential pressure signal into a flow signal from a DP flow meter standpoint. What we're talking about from edge now is collecting data at the machine, processing the information at the machine, and then outputting a number to a management system that allows the management system to understand how effective that solution is. And then, of course, the cloud, don't be scared of it. It's a server on somebody else's desk.
Good. Thank you.
Mm-hmm. So when we talk about specifically, we look at the integration. I mentioned the alphabet soup. I mentioned that we're getting machines from different solutions. You think about it from a food and beverage manufacturer standpoint, that packaging machine may come in from Germany. The bottle filler may come in from Japan. Well, I guarantee you, if it came in from Germany, it's probably got a Siemens system on it, so it speaks German. If it came in from Japan, it's speaking Omron or Mitsubishi. We're not going to get all the same units. I mean, you can typically specify the control systems that go onto these machines, but then the manufacturer adds an extra 10 or 15 or 20 or 100 grand, different depending on the complexity. So rather than worrying about that, it's more about translating the information that we need to be able to deliver. It's understanding that even if I have a German manufacturer system, I can take that data using OPC, using OPC-UA, using Modbus, using Profinet. I can get that information out and then use that in the systems appropriately to deliver the data. Now, today, even in the IT world, I mean, the IT world has come up with some innovative technologies over the world or over the years. But the reality is, in the OT world, we use state-of-the-art technology with 20 years proven reliability in the field. Very rarely do you find something in the OT space that's just been released and just been updated or has a 5-year life expectancy. We need that life expectancy to be 20 years, to be 25 years, so we can get the true return on our investment of that machine. So adapting and building the networks necessary to connect those islands automation, and then using the protocols, the industry standard protocols to extract the data and push that to a management system so that you can understand what the OEE, overall equipment effectiveness is, what the reliability is, and then incorporate that in with your MES system, with your maintenance management systems. Now we can do that in a secure fashion so that you can have real-time understanding of how those systems are operating.
Good. So it is fair to say that regardless of the OEM, that we can find a way to collect the data we need?
Yes, sir. Today, even if the OEM is still using the what they call now OPC Classic, which in my day was OLE for process control. and OLE, by the way, if you don't remember what that is, it was Windows for Workgroups. So before 98, before time began, there were technologies that we used on the factory floor, and that's really migrated from the traditional Windows environment to an OS independent environment with OPC-UA. But again, not everybody can speak that, so you fall back to Modbus TCP, probably one of the most prevalent protocols in the industry today. Is Modbus. The problem with Modbus is everybody does it different. It just defines registers. It doesn't define how you use those registers. So everyone has to be mapped. And there are newer technologies like hard IP, which deliver you the diagnostics, the functionality from the device itself to understand all the way down to the plant floor what kind of performance you're getting out of the instrument, and then be able to extract that and bring it up to your management systems.
Thank you.
Mhm.
And lastly, on this slide, if you get any pushback from selected decision makers regarding data integration, where is it likely to come from? What are some of the roadblocks?
For all our IT brethren that are out there, I'm one that kind of straddles. I'm on the dark side and the light side, depending upon which side you're sitting on. You know, that's usually where the big problem is. It's usually how do I connect to the systems? How do I get those islands of automation connected back and delivering a real-time piece of information that can be utilized? Rarely do you see a problem once you've justified it, but the problem is justifying it, because putting in a network is extremely expensive, but it doesn't make you make more product to have that network. It doesn't make you make that product better. So you have to justify it from the knowledge standpoint. How do I know what I'm doing? How do I know how that machine's operating? That's really where you get your return on investment, is from the data, not the connectivity itself.
Thank you.
Mhm.
So we've talked about the sources of the data. We've talked about data integration or data flow. It has to go someplace. It goes someplace in order to manage it. So, John, can you shed some light on that?
Sure. Thanks, Tom. And kind of picking up right where Ed had left off. You know, we were talking, or Ed was talking about that edge device and its responsibility of consolidating and transferring that information, which again is typically in kind of a DMZ, right? So it is in the no man's land, protected by firewalls on both sides to be able to collect that information and send it off. So once it gets sent off, it can be an on-prem system traditionally, or more typically these days. This is a cloud-based system that data is being transitioned to, and then from there, it's democratized. You can use it for many different purposes. You can use it for comparing facilities, comparing equipment within facilities. For the sake of this discussion, one of those use cases is for maintenance. So the conversation we're having today is specifically around leveraging that data for computerized maintenance management. And when you boil it right down to its fundamental components, we're really talking about using that data for work orders for equipment. And we'll get into how we're able to do that in a more prescriptive fashion here in a couple of slides. But at its core, CMMS systems are really around asset management. We have all of our different assets that are usually arranged according to the ISA S95 model. For those assets, we have documentation, we can have pictures, we can have standard procedures, we can have bills of material for replacement parts, we can create work orders, even in an ad hoc kind of fashion. The operators can create work orders from out on the plant floor if they notice something that needs attention. And then through integration, we can actually have the equipment or the control system be more prescriptive and generate work orders based on some of the condition monitoring devices that Tony had mentioned earlier. So we also, more holistically, beyond just simply creating the work order, the CMMS system is really designed to see that entire maintenance process through, from assigning work orders to technicians who are either qualified to work on the equipment, obviously independent of time, making sure that we're aligning our different shifts correctly, but qualified to work on that piece of equipment. And it could be one person, it could be a team of people. So you can take your maintenance team and divide that into different sub teams by system or area of the facility to dispatch those work orders to. It's also where you're prioritizing things. So obviously, something fails or has an issue mid-process, is certainly going to be of higher priority than either PMs or something that is being prescribed by the control system or the detection devices that you have out there.
So
Go ahead, Tom.
can we tailor a dashboard like this for different users?
Yeah, you definitely can. So the dashboards that you see and the example that I have up on the screen here, you can see is for Fix, which is one of many CMMS platforms. There are a number of others. Maintain X is being advertised on the radio all the time now. Upkeep, Limble, MVP1, these are all CMMS systems that at their core are really designed for the same function. Different capabilities, clearly everybody's got their shtick. But yes, the dashboard that you're looking at is kind of widget based, and it can be tailored by the individual user in order to allow them to see what is pertinent to their function.
Okay.
I do want to touch on the AI too. I know it's a huge, buzzword, and every one of the CMMS providers that I mentioned is going to offer, their own flavor of AI because their marketing department told them they had to. But it really is, since you have the data that's coming from the control system, again, through that edge device and up into the cloud, the real hard work, if you will, for being able to apply that data to any kind of AI model has been done for you because it's already structured. So within a CMMS system, you're going to be defining your facility in an S95 kind of way, enterprise site, work cell, area equipment, all of that. You are, just by virtue of using the CMMS out of the box functionality, providing a lot of context to that data so that when you're mapping those devices and sensors that Tony was mentioning into that modeled out CMMS platform, you have a very powerful data source to be able to enable that AI to go into. And it's going to do things like looking at historical those detection device profiles to see what that profile of vibration looked like, for example. We're beyond the time of just setting high and low limits for different devices. And now you have things like an AI engine that's constantly looking at signals like that vibration. And it's looking at events that occurred when, what was the vibration level historically before I took this motor out of service. And I don't have to explicitly control those parameters for every device on the plant floor anymore. The model is learning that for you over time and becomes more and more prescriptive the bigger data set you end up that you end up building.
By prescriptive, do you mean that the AI can, for instance, submit a purchase request?
The AI can submit a purchase request. A more typical use for it would be the AI prescribing work orders based on the state of the equipment and the parts inventory that you have, right?
Yes.
So it's going to prescribe a preventative maintenance work order based on the profile of how the equipment is running, the current parts that I have in stock, the production schedule that includes that piece of equipment. So it's going to try to take all of those things into consideration and schedule a PM at an ideal time.
I see.
I do want to touch on the mobility aspect of CMMS systems, just because of the nature of maintenance technicians are all over the place, right? We can't have a computer. A lot of them do, just because of the controls type access that they need on a regular basis. But as you know, maintenance technicians are responsible for a broad geography within a facility of a lot of different equipment. The mobility is really an important piece. So a lot of these companies have invested pretty heavily into mobile platforms. You see one here as an example. That they typically do very similar things where I can scan assets. You can print a QR code and apply that to different assets. You could walk up and scan that QR code and bring you directly to that asset to look at documentation, to look at historical work orders, to look at current open work orders, to look at upcoming PMs. You really have that information truly at your fingertips. And when you are going from one work order to the next, you're able to keep accurate record of the time that you're spending on each work order in location, the parts that you're consuming in location, because accuracy and sanity tend to struggle when I'm going out. I'm going through all these work orders. I get back to my desk only to be faced with another hour or two's worth of work, recording all the parts that I use, putting in requisitions to replace those components, recording all my time against these work orders. This mobile application allows the maintenance team to be able to do that out in the field. And when they can work their way, when I'm done with the work order, I'm done with the work order, and I can see all that at once. The bottom bullet point there, I also wanted to kind of point on that inter-team messaging. It's very simplistic. I mean, this is literally like going onto a Teams chat, right? For within the CMMS platform to be able to talk to colleagues. And that can be segmented into groups as well. So I can converse with other technicians that are on my same shift. For example, like, hey, hey, I need a hand with something. Can you come over here for a second type of thing? Or you might have some specific groups for subject matter expertise, right? Depending on the system or solution that or part of that plant that you're working in, you could have a subject matter expert segment or group within that platform as well. So if you need to reach out to someone for detailed information on something or how a process is running, then you have a pretty direct method for being able to do that. So that inter-team messaging is simple as it is, because we're all used to using Teams every day in, day out. It's a value added component.
Thanks, John.
All right, as Ed was kind of talking, some of this is redundant from a technology and data flow perspective. But what is important to acknowledge here is kind of on the right-hand side of this, we have a variety of control systems, a variety of different software packages from a historian standpoint, a variety of protocols. I mean, Ed had mentioned Modbus, Ethernet IP is another one, MQTT you're hearing about all the time now. And all of those are different data sources that can be ingested by the CMMS system and frankly, used for that and many other applications. On the other side, on the left side of the slide, we have different business systems that we're interfacing with. So we'll talk about different points of integration coming up in a second here, but think of purchasing. If I just spoke right through the mobile app on the last slide about leveraging that application for recording time and parts that I'm using. So obviously I want to replenish the parts that I'm using. Can I do that directly from my CMMS system? Because we use SAP or we use Dynamics 365 or Sage or Oracle, what have you. And the answer to that obviously is no, right? We need a purchase order to come from our system of record that our purchasing team uses, but the integrations between the CMMS platform and whatever flavor of business system you happen to be using will enable that replenishment to occur.
Okay, so when we talk about data management, can we also use that data to inform production?
Yeah, we definitely can. So another of those business systems, and I don't remember if it was Tony or Ed had mentioned MES or manufacturing execution systems. That's where typically your production schedule is going to live in your MES system. And that's something also that CMMS and its awareness of whether a piece of equipment is in service or out of service may well influence or advise your MES platform as to whether something can be scheduled to run on a given line or piece of equipment. Because if my CMMS is telling me that this blender is down, then my MES needs to be aware of that so that we can work the production schedule around that piece of equipment.
Thank you.
For sure. Some other examples of integration. I did speak earlier about that, automatic work order creation that can be done. We specifically talked about it in the context of a use case for AI, but it can be more simplistic than that too. So if you do have, a SCADA system and you have different alarm classifications within your SCADA system, maybe we're going to agree or design the system around a given severity level, and anything that is that severity level or higher, we're going to automatically create a work order when an alarm condition occurs, right? So you could do something like that. And through the APIs that are exposed by any of these platforms, we can leverage that alarm to automate some of those functions. So in this example, creating a work order. Managing equipment state. So that's the in-service, out-of-service that I spoke of before. We can go directly into the CMMS and say that, like the example I gave, this blender is out of service for whatever reason. A seal is blown and I don't have a replacement in stock or what have you. Even if it's only temporary, right? It doesn't have to be out of service for an entire shift. But for the sake of OEE calculation and performance monitoring, we want that to be accurate. But it doesn't, to my point, have to be done by operators as a selection. We can have that advised again by the overall control system that's controlling the equipment. The next two bullet points kind of go together regarding context. So we have work orders. We'll take the pump example that Tony gave earlier. We have a vibration sensor that's on a pump, right? That information, again, via that edge device is constantly being fed into the CMMS system. So if I'm using my mobile app and I walk up to a pump and I scan the QR code attached to the pump, or I manually look it up within my S95 model that I have, you go to that pump and you go to the meter readings tab, and you're going to see a trend of what that vibration looked like over time. So as I'm looking at different historical failures, current state, if I do have a work order that was automatically created from either AI or as prescribed by a control system, and I want to get a little more context around that before I dispatch it out to my team, you have that information readily available to you right within the CMMS system. Regarding other context, so beyond just meter readings, if you want to provide other context to a work order, such as the time of failure for a specific device in terms of like timestamp can be prescribed, the state that a piece of equipment was in at the time of failure, like I had a system like maybe a milk separator, right, that reported a failure when it was doing a desludge operation or something like that. You can report the state of the equipment when something occurred. You can even support operator comments in this way, right? So if I have the ability within my SCADA system for an operator to be able to bring up a faceplate for a device and just add, there's something built into that faceplate that just says send a message to maintenance. I don't need to create a work order. I just want to create some contextual message around this piece of equipment or this asset. You can do that as well. So that context is so rich and deep that it's extremely powerful. Material management, I spoke to a little bit earlier. It's that integration between CMMS and whatever purchasing, whatever ERP you might be using for purchasing. Really small operations, this may be using the CMMS to print out a requisition that you're going to physically take to somebody and say, would you please order these? A larger organization is going to have an actual integration that's going to leverage the APIs of both systems to be able to advise. So if I use a part out of my maintenance inventory, it'll automatically order a replenishment. The other thing may work with large organizations, your maintenance inventory is in your ERP system. So customers that are using SAP, their maintenance inventory is within SAP. So an integration going the other way is going to keep that the current state of that inventory in your CMMS system all the time, so you don't have to bounce between two systems to be able to get a record of this is what I need. Now let me turn over to my ERP system to see whether I have the parts that I need to be able to perform that function. So you have everything all in one place. Right. Reporting and visualization, we talked about the information that we're getting from the process. And then obviously there's that goes several layers deeper in the onion, right? How many hours did I spend providing, or supporting a given piece of equipment, or how many dollars worth of parts that I do? How frequently is something failing? All of those are different things. The availability of a piece of equipment as far as in production, out of production over a period of time. All of those metrics and that analytics can be performed right directly out of the CMMS system.
Can the reporting and visualization function be expanded or extended into, let's say, the raw material issues, or a lot of process conversation here, but also packaging, warehousing, for instance?
So drawing a correlation between maintenance and work performed on assets and either the product that you're running at the time or different like raw materials, packaging, consumables that you might be using at the time. Is that what you're asking?
Yeah.
Yeah, absolutely. And this gets into a little bit of a higher level discussion on what are referred to as industrial data ops platforms that are going to consume information from multiple sources, the CMMS being one of them. Another might be a historian, another might be the MES system. So you have a laboratory information management system. It's going to take information from all of those and create context. Just as I am with that S95 model within the CMMS system, you're going to expand that to include information from other systems. And it's through those types of data ops platforms that you can start to draw those correlations. Like my MES was running this batch or this SKU, and while that was occurring in this totally disparate system, my CMMS was reporting an increased number in failures over time.
Got it. So do we have any questions that this team can address?
There is one question in the Q&A. It says, what's the best way for a customer to determine their cost of downtime? I mean, if you cite um, the marketing people in the area, I mean, Aberdeen Group, which has been cited many times, suggests that loss per hour is around $260,000 per hour in the food and beverage manufacturing. But that's completely dependent upon the type of product you're making. I mean, how fast you're making it, how, you know, in a bottling operation that's doing, 1,000 bottles a minute, that's a pretty significant dollar amount when you translate into a specific loss. But it also has to be about how your system is built, and if one machine goes down, is there surplus in the line to keep a packaging machine running while that packaging machine runs, bringing up the machine that just went down. I mean, the reality of that is, if you've got that surplus built into your packaging line, you might not have any loss at that particular time because you've got the capacity to be able to send that through. So it's really dependent upon your specific instance as a manufacturer, what the cost of your product is, how fast you're running the line, are you running one shift, two shifts, three shifts? All of that plays into the discussion to determine that actual cost of downtime. And then you have to look at add in the employee base and all those other things that come into the discussion. That's just kind of my 2 cents. Anybody else want to comment on it?
I agree.
Looks like we've got another one there too. Go ahead, Tom. I'll let you take it.
No, go.
It says from Maud Telliard, thank you for the question. Have you seen challenges in the meat industry regarding firewall facilities, regarding the firewall facilities have when it comes to connectivity collecting data that we are talking about? Somebody want to take the firewall discussion? I'd be happy to do it.
The short answer is certainly yes, and it's not limited to the meat industry. I forget what you had said earlier, Ed, earlier. It's like the white hats or the black hats, or the good team or the bad team. And there's certainly a lot to be discussed between the IT and OT organizations when it comes to cybersecurity. It's an extremely important topic, particularly for larger organizations. And it's one that requires the unique skill set and kind of knowledge on both sides of that fence, because IT sees OT as a black box. OT sees IT as a pain. So it is really, we find ourselves as integrators in that situation very frequently, because we do have, and I'm sure Ed can kind of speak to this too. We have a team of industrial IT, and that is their job, right? They are that bridge between OT and IT, because they can speak both languages. And in order to have a productive conversation, you really need to have those types of people involved.
I think in particular in the meat industry too, there's I've been to a few plants, a lot of manual operations in the meat processing world. And it depends on if it's cooked or processed or just cut and packaged. I mean, so there's really there's actually multiple. There's the frozen, there's the cooked, there's the processing just to take the raw meat and prep it to sell. So there is a lot of manual processes there, and a lot of that integration is more focused on the packaging side of the system versus the let's say the manufacturing side.
Yeah.
But I agree with John completely. You know, having someone that can translate those messages between the OT and the IT, because a lot of times they bang heads. I think it has a huge impact on the outcome. And what it boils down to is the architecture. When I talked about zones and segments and things like that, that's key. So let's say the the packaging machine versus the I can't even think right now. We're the palletizer. Got it. Too many P's, guys. Versus the palletizer. Those are two separate machines that are typically not connected together. So it's that connection, it's the architecture, and then it's the discussion with the IT that needs to take place. So I completely agree with you, John.
I'll jump in here for just a second on the topic of IT. Starting from the ground up, we encounter, you know, with the device level, we encounter some of the first objections, primarily because of wireless, from IT. And you know, the IT, we have to remember, has a very incredibly tough job. They've kind of got that thankless job where they're like the left tackle on a football team. Nobody knows their name until you're putting the quarterback on a stretcher. And they have a responsibility to protect the facility from a security standpoint, to control everything that comes in there. uh, you know, to anybody out there that either is IT or is looking to approach doing some of this instrumentation all the way up through these systems, the best advice I can give you is to include IT as soon as possible. I can tell you confidently that we can do this securely across all three of these, you know, from data sources to data flow to data management. We can do it securely and safely. But many times I've seen IT err on the side of killing the initiative if they haven't been included early on and have an understanding of how it's going to affect the facility.
But
Great point.
that data security issue is always the driver for those kind of conversations.
Well, it's not just data security. It goes both ways. I mean, there's privacy, and then there's network security, and then there's risk. You know, what 4 points or 3 points are you having to deal with? So yeah, I agree with you, Tom, that you have to evaluate. You can't just do one. You have to think about them all.
I think that concludes our webinar for today. It is almost 3 o'clock. I would encourage those who are still attending online to consider signing up for the Disaster Prevention and Contingency Planning for Operations webinar scheduled for October 23. And again, go to fpsa.org/fall. And in fact, you may even consider joining FPSA. It's a great group. Lots of good content and lots of good networking. That concludes our meeting for today.
Thanks, Tom.
See y'all.